Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In the Earth sciences, the significance of space weather and the Earth-Sun connection is becoming more and more undeniable. A scientific case is now being made for the role of solar activity and changes in the Earth's geomagnetic environment in earthquakes and other natural disasters. If solar activity and other factors do contribute to earthquakes, then one of the most important questions scientists can ask is, can the likelihood of earthquakes be predicted? Today, the founder of Space Weather News and the Mobile Observatory Project, Ben Davidson, along with scientific colleagues, has developed an app that attempts to do just that. We asked Ben to offer an introduction and overview of the app's genesis and development, and the scientific foundation behind it.
In essence, we began conceptualizing the app at the beginning of 2016. We did a Kickstarter campaign to raise funds for the app in the spring of 2016. $120,000 was raised in about 2 weeks, and unfortunately that is what it takes to really build an app and get all the servers going and have back-end programs that you create and front-end app programming that the user actually experiences when they're using the app and things like that. And it just came out December 20th of 2016, right at the end of the year there. At this point, we are just trying to spread the word about it. And I don't want to say we've become content in any way, but we are extraordinarily encouraged by what has happened in just the first few weeks of the app being live. Of course, in the 30 days of the beta period we had with about 200 users before that as well. And since the earthquake forecasting model portion of the app has been in play since the end of this past summer in 2016, it has been very encouraging as well. So it's sort of been a process that we didn't really see coming, so to speak. We would have thought something like this would have taken a few years, but in essence, the app really sort of came together in 2016. We got some good back-end programming, some good front-end programming, and now we have something that right in the palm of your hand can talk to you about earthquakes and space weather. You know, there's a lot of skepticism when it comes to discussing space weather and other electromagnetic signals and precursors of large earthquakes to come. And that's understandable because the efforts to do just that thus far have been, somewhat failing. Most of the most used space weather indices like sunspots, solar flaring, solar wind speed, geomagnetism, like how big of a storm we get, how high the KP index goes, things like that. Those do not seem to be directly correlated with seismic events, although quite a number of interesting coincidences do occur. It is difficult to get past that. However, most of that information is becoming quite outdated and becoming outdated quite quickly. That comes from 2013, 2014, and in 2015, we wrote the initial paper on how the solar polar magnetic fields are triggering magnitude 8 in larger earthquakes. We did that with Dr. Kongpop Yen and with Dr. Christopher Holloman from The Ohio State University, and followed that up with a second paper in 2015 as well, also on the topic of how a lesser well-known space weather factor, coronal holes, and more importantly, their distinct electromagnetic output and their interplanetary magnetic fields that reach out and touch the planets, how that actually is the thing that we should be looking for with earthquakes, which was never really studied in this way before. And what's interesting is most of the headlines from third-party reporters on some of the studies that were done by the USGS and others back in 2013, 2014, maybe before that showed that there was no way to prove that the sun had anything to do with earthquakes or to predict earthquakes in any way. That's the kind of thing where back then The paper didn't even discuss coronal holes, and the paper didn't make a blanket statement about the sun or about predicting earthquakes. It just said, hey, when we look at sunspots, solar flares, et cetera, when we look at these specific things, we don't see anything. And thus far, the predictive models don't seem to work thus far. And so while you'll see reporting on this that has really skewed public perception, the reality of what exists right now is setting the stage of what we know doesn't work, what the standard is for figuring out what does work, and moving forward from there. Now, the first thing we did was attempt to prove that the sun triggers earthquakes. We had the 2 peer-reviewed papers in 2015 on that, and New Concepts in Global Tectonics. But almost immediately after that, we began working on compiling pre-seismic factors that had been reported in studies throughout the last few years and the last few decades. Everything from patterns scientists thought they saw in foreshock activity, and published in the 70s. Well, we got a lot of time to check and see if they were right since then. There have been papers published about outgoing long-wave radiation anomalies or total electron content anomalies, problems or fluctuations with the L-shell magnetic fields, GPS disruptions, EMF signals that sort of crop up out of nowhere, positive ion emission, earthquake lights, animals acting funny before an earthquake. The list does go on and on. These things are all published, and they've been published about for years, some of them decades. We have a lot of time to see how they work. Turns out there are very few that work better than others. A specific kind of foreshock analysis, a atmospheric pressure analysis, and outgoing long-wave radiation in terms of looking at where we are to be seeing larger earthquakes soon, imminently, as in the coming hours to just a few days. In terms of timing it, which, when you put those areas on alert, or when we think the Earth in general is more ready to have these bigger earthquakes, well, then that's when we look back to the original papers we did back in 2015, where we absolutely agree with everything the USGS actually said. We know that there are third-party reporters that said, oh, the sun can't trigger earthquakes, says the USGS. Well, that's not what they said. What they said is specifically solar wind speed, geomagnetism, sunspots can't. They did not close the door and overreach with their findings. That is something that was done by other people. But using those things called coronal holes and their effects on the Earth, you are able to get a pretty good idea of the timing, the ebb and flow of Earth's upticks and downturns in large earthquakes. What's really excellent about this is it doesn't require any trust, and it doesn't require any advanced knowledge. The good thing about are posting our alerts on this app and are posting our alerts on Twitter as well is anyone with access to the internet can go and see what alert was posted when. It's clear as day with big red lines and big red stars and yellow lines. It's on basically a global satellite map to show you which areas of the world are on alert. And of course, we chose Twitter as opposed to one of our own websites because that is a third-party timestamp that we can't hack Twitter. We can't go and manipulate the times of these things. It's essentially a permanent public record of what happened when. And so we are constantly doing this forecasting. It's not actual predictions of events to come. It's using all of those factors, the atmospheric pressure, the outgoing long-wave radiation, timing it based on the sun, taking a look at what's happening beneath our feet as well for some of the more robust foreshock patterns. And we take the entire world's active fault lines and reduce them to about 10 to 20%. Now, you say 10 to 20%, that's still a fairly large chunk of Earth. Well, at this point, I would have to say that these alerts are more informational, educational, rather than actionable. Not the kind of thing where we could put a city on alert like is put on alert for a hurricane and tell a government to commit resources and evacuate people, at least not yet. It's more informational, but we have to take an intermediate step to go from no earthquake forecasting to being able to give hurricane-like warnings. The what is tantamount to the practical equivalent of prophecy would probably be very unreasonable. This, we claim, is the first good intermediate step. And in that 10 to 20% of Earth's active faults that are identified at any given time, we're capturing about 70% of the magnitude 6 and larger earthquakes. And we've had streaks of 4 in a row, 5 in a row. We had a streak of 10 in a row, the kind of thing where if this was just random luck, and you just sort of randomly placed your alerts around the world, it would be about a 1 in 10 million chance of getting 10 in a row. And so specifically some of the big hits that have really taken place, and there's a list of this that can be seen on quakewatch.net. The largest earthquake to happen during the run of the model was a 7.9 that struck Papua New Guinea on December 17th, and it was in the alert zone. There was a pretty well-known magnitude 7.8 that struck New Zealand back in November, actually caused a bit of a tsunami. It pretty much matched the largest earthquake they had ever had there. That one was in an alert zone as well. The only 6-pointer to strike California during the last few months, indeed, the last year and a half or so, was back on December 8th, 2016. During one of the only red alerts California has had. We got the 6.6 in Italy October 30th as well. We also got the 6.9 that struck El Salvador very close to Thanksgiving. There have been about 25 total large significant earthquakes. 18 of them have been in areas that have been on alert according to these alert maps. Now, that's the kind of thing where by random chance at putting 10 to 20% of the world on alert, out of those 25, we actually should have just randomly got about 2 to 3 to 4 of those earthquakes. But we shouldn't have gotten 8. We shouldn't have gotten 14. We certainly shouldn't have gotten 18. I was very happy that the Thunderbolts recently posted my talk from their last conference because it was largely about some of the most promising pathways forward, and this really was one of them. I know you guys will be kind enough to go ahead and put a link to that talk right in the description box, so if you're listening to this Space News program, a link to that talk should be right down below there. This is one of the things I was talking about, and so far it is quite fruitful. I have to imagine that it would have been virtually impossible to come up with the forecasting model or even see how the sun was affecting earthquakes to begin with within the box of the mainstream only. It's only by blending, the volume of work that the mainstream has given with some of the necessary adjustments that need to be made with some electric universe principles. That is really what is required in order to see, understand, and really come up with a way to make this information useful.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.